Good evening. Today's session we are going to see about the DC source. What is DC source? Direct current. DC source means direct current. Direct current is the universal flow of electric charge. DC source refers to sources of electrical energy which are associated with constant voltage and current. And this diagram shows this is the DC current. DC current. This is the pulsating current and variable current. This is alternating current. AC current. Now, what are the DC sources? From AC source using rectifier and filter circuits, then battery, DC sources battery, that is battery means chemical to electrical energy, then thermocoupler, static electricity, solar energy, that is a PV as well as thermal, then thermo generators, dynamo generators, and last one is the fuel cell. This is the DC voltage source, and this is the current source. What is solar energy? The sun is the biggest source of renewable energy for the earth. In fact, even though the earth receives only a part of the energy generated by the sun, that is the solar energy, that a part of solar energy is also tremendously huge. The earth receives the solar energy in the form of light, that is the radiant energy and heat energy. So the solar energy can be converted into heat energy, light energy, and photosynthesis. Photosynthesis means there is a biomass radiant energy, it's called as. The principle of solar. What is the principle of solar energy? The semiconducting material in the PV cells are doped to form a PN structures as an internal electric field, and the P-type silicons has the tendency to give up the electrons and holes, while the N-type negative silicons accept the electrons. When the sunlight hit these cells, the photon in light exceeds the sum of the electrons in the semiconductors to becomes a electron holes. If you see the diagram means you can clearly understand. Since there is an internal electric field, these pairs are induced to separate. So the electron moves to the negative electrodes, while the holes moves to the positive electrons. So conducting wire is connected between the negative electrodes and the load, and the positive electrons in series to form a circuit. So as a result, what happens? The electric current generate to supply the external load. That is called as the PV effect works in the solar cell. What is the principle of solar energy? See the diagram. N-type semiconductor, P-type semiconductor. Between this there is a depletion layer, depletion zone. When the sunlight falls, the P-type semiconductor, it induced to the depletion zone to the N-type semiconductor and this is the circuit. What is solar cell? Single solar cell. Solar cell is a two-terminal power generating device. One is the positive, that is the anode, and second one is the negative terminal, that is the cathode. So solar cell is a two-terminal power generating device. Now what does a solar cell do? It directly converts the sunlight into electricity. No sunlight, no electricity. When there is a sunlight, then electricity will be produced. This is the principle of the solar light to sunlight into electricity. Now solar cell to solar PV model. Why we go for PV model? See, if we take a single solar cell with one single cell rate, current 5 amps, volt 0.5 volt and power 2.5 watts. So which generate 15 watts using single solar cell. How can we generate higher watts using single solar cell? It is not possible. So in order to get a larger power, many cells are connected together in series and parallel. That is called as the solar PV modules. So we go for solar PV modules. So solar PV modules is a device in which several solar cells are connected together to generate more power than a single solar cell. Single solar cell, that is called a solar PV model. So a solar PV model is a device in which several solar cells are connected together to generate more power than a single solar cell. So what are the different type of these are the different type of PV models. Model images have been given here. Solar folded PV system. This is the energy source. Sunlight, there is a energy source. Then PVRI here. Then we need of power conditioning inverter, load centers, power distributions, battery, and electric utilizers, and here the load. So the total components and subsystems that in combinations which convert the solar energy into electrical energy suitable for connecting to a utilizational load. See, motor to load a cell, then load. Now, what is solar thermal energy? Solar thermal energy. From the diagram, you can easily understand what is the solar thermal energy. So, utilize energy from the cell to heat a fluid to a higher temperature. These fluids then transfers into heat to water, which then becomes a superheated steams. These steams is then used in a turbine. Turn the turbine of a power plant, and then this mechanical energy is converted into electricity by a generator. Type of solar cell: collectors. So a collector, what is a collector? Collector is a device which absorbs the incoming solar radiations which convert into heat and transfers this heat to a fluid. So now the solar collectors are either non-concentric or concentrating. In the non-concentrating type, the collector area, that is the area that intercepts the solar radiations, is the same as a observer area. In this type of, the whole solar panel absorbs the light. So concentric collectors has a bigger internship than observers. And these are the type of solar energy converters: non-concentric collectors and concentric collectors. In non-concentric collectors, there are flat plate solar collectors, uh, evacuated tube solar collector. In type of concentric collectors, there are parabolic, power tower receiver, parabolic disc collector, and Fresnel lens collector. And these are the models of the flat panel. This is the flat panel type. This type of panel is also used. This is evacuated tube panels. Then parabolic. These are the positions models. Parabolic disc. Flat plate solar collector. These collectors are simply made up of metal box that have some slot of transparent glaring as a cover on the top as a dark colored observer plate. These sides and bottom of the collectors are usually covered with insulations on the top to minimize the heat loss to the other part of the collector. So the solar radiation passes through the transparent materials and hit the observer plate here. So this plate heats up and transfers the heat to either water or air that is held between the glaring and observer plates. Sometimes these observer plates are painted with some special coatings to design the observer and retain the heat better than that of the traditional black paint. So these plates are usually made up of metal that is a good conductor, usually copper or aluminum. And this is the model of the non-concentric flat plate solar collector. And this is the parabolic through collector. This is the model, parabolic. See the image. Parabolic means it is a line focusing type collector. In this type of collector, the solar radiation falling on the area of the parabolic reflector is concentrated at the focus of the parabolic. So when the reflector is manufactured in the form of through the parabolic cross-sectional and solar radiation get focused along a line here. And a working fluid, some synthetic oil or water flows through it inside the pipelines. So and the focused solar radiation falls on the observed pipes. The fluid get heated by the higher temperature. Then the heat absorbed by the working fluid is transferred to water for producing